All right, so let's talk about these two optional problems that you had that you could try. So the first problem, we're going to go through the same process. I'm assuming you've already done the first three and that you did okay with them, and that's why you tried the optional one. So I won't be as rigid with our process. I'm going to move through it pretty quickly. So the first thing we do is we show that it works for the S sub 1 case. So that means I take from here to here, and I plug in 1. So I have 2 to the 1 minus 1 power equals 2 to the 1 minus 1. So 2 to the 1 minus 1, that's 2 to the 0 equals 2 minus 1. Anything to the 0 power is 1, so 2 minus 1 is 1. We showed that it worked for the S sub 1 case. So now we assume that it will work for the S sub k case. All right, now that means we have to write out what the S sub k case is. So again, for those of you that have already watched the videos, you know what this process is, and I'm guessing that for most of you, it was not these first two parts that got you in trouble. Okay, you were able to at least come up with this. Better write the right thing here. And now we're going to prove that it works for the S sub k plus 1 case. So prove S sub k plus 1. Now, that's going to be exactly what we've written above. Except we're going to add on, and instead of k, we write k plus 1, and then we have k minus 1 is our original expression, equals, and then again, replace our k with k plus 1, and there's what we're trying to prove. Now, just like in the previous videos, we already have an expression for this part of our equation. So I know that I can replace that whole expression with what it's equal to above, which is 2 to the k minus 1. Now I keep adding on what we have written there, which is 2 to the, let's call that k plus, k, that's just k, right? Because k minus, plus 1 minus 1 is 0, equals 2 to the k plus 1 minus 1. All right, so now here's where things get interesting. So I see something interesting happening, but I want to rearrange this a little bit, okay? So I'm going to take those two terms, and I'm going to write them beside each other. So it'll look like this, and I'm going to use the same colors to help us see what's happening. Now, this is where it gets a little bit tricky and where some of you will probably have a little bit of problems understanding exactly what's happening. But I want you to think back to something like this in Algebra 2, for example. You might have done something like x cubed plus x cubed. And you know when you add like terms together, that's really saying 1x cubed plus 1x cubed would be 2x cubed. That's essentially what we have here. And let me show you what I mean. So we have 2 to the k plus 1, I'm just writing these in the same color so you can see where I'm getting everything, minus 1. And then we're trying to show that these two things are equal. Okay. So really what I'm saying is I have 2 to the k, and I add another 2 to the k to it. So I really end up with 2, let me use white here, 2, and I'll use red now, 2 to the k's. And then I still have that minus 1, and I want to show that this is equal to 2k plus 1 minus 1. Now, again, this is really close, but we have to understand our algebra skills and what's happening with exponents. So first of all, this 2 out in front is really the same thing as if we were to say 2 to the first power, okay? Go back to your algebra, okay? So back in Algebra 1, probably, you did stuff like this. You did x to the first times x squared. And most of you at home are saying, oh, I know, I need to add those exponents together. And that's right. And normally we would just skip this step and just go right to x to the third. But here's the thing. In the expression that we have right here, we want to show that we have the same base, 2, raised to 2 different powers, and we're multiplying those. When you multiply like bases, you add the exponents. So what we can do here is we can say this is really the same thing as 1 plus k, and then minus 1 equals 2 to the k plus 1 minus 1. And then, guys, you have it, right? So that 2 to the 1 plus k is really the same thing as saying 2 to the k plus 1. I can just rearrange the order in which I add, and now I've got it. All right, that one was pretty tricky. Let's try the next one. So I apologize to anyone who may have started this one before I caught the typo, but originally on your assignment, it had this as a bunch of plus signs in between each of the parentheses, and it should have all been a product. So if you tried it with the plus signs and got really frustrated, you should have, because it didn't work. But with the multiplication in between, it will work. So we'll go through our process. First, proving that it works for the first term. And to do that, once again, we just focus on the end here. And we're going to plug in 1 for n. So 1 plus 1 over 1 equals 1 plus 1. And what we've got is 1 plus 1. Well, yeah, that's going to equal 2 on both sides. So for the first case, it works. Then we check, or we assume, sorry, that it will work for the s sub k case. Now to do that, we have to actually write out what the s sub k case is. So that's going to be 1 plus 1 over 1 times 1 plus 1/2 times 1 plus 1/3 all the way up to, and this should not be pluses there, that should be multiplication, 1 plus 1 over n, and we want to show, sorry, not n, k, and we want to show that that's equal to k plus, or we're assuming that that's equal to k plus 1. So the last part of this then is to prove that this will work for the s sub k plus 1 case. So to do that, we have to actually write out what the s sub k plus 1 case is, and that's going to be 1 plus 1 over 1 times 1 plus 1 over 2 times 1 plus 1 over 3, all the way up to 1 plus 1 over k, and then we go one more term, so 1 plus 1 over k plus 1. And we want to show that's equal to, plug in k plus 1 for k here, so it'd be k plus 1 and then plus 1. Remember, the whole point of writing out the s sub k case is so that we can use this in our k plus 1 case and replace it. So you should see that right here. Okay, so that whole entire thing we can replace with just k plus 1. So I'm going to do that. This entire expression is the same thing as saying k plus 1. All right, now we've got that, but we still have the rest of our expression to write. So I still have this part of my expression to continue writing. So I've got times 1 plus 1 over k plus 1 equals, and then this is just k plus 2. So this will come together pretty quickly once you distribute, and that's what I'm going to do. I'm going to think about taking this k plus 1 and multiplying it by 1, and then multiplying it by 1 over k plus 1. And maybe you're seeing where this is going to go. When I multiply k plus 1 times 1, that's just k plus 1. When I multiply k plus 1 times 1 over k plus 1, what I get is this, k plus 1, we'll write it over 1, times 1 over k plus 1. Okay, and remember, we're trying to show that this is equal to k plus 2. Guys, you should right away notice that's going to become a giant 1. So really, this whole thing is just 1. So what I've got is k plus 1 equals k plus 2, and then, yep, this is k plus 2 equals k plus 2, and we've shown that it works. All right, nice job. If you tried this, If you have any questions still, please let us know.